Orbiting solar observatories carry a number of complex experiments devised by scientists in NASA, other government agencies, and universities. OSO-2 was launched in February 1965 and successfully placed in orbit. 7 of the 10 experiments aboard returned new and useful information on the condition of the sun at solar minimum. This included measurements on the solar output in the near ultraviolet, X-ray, and gamma-ray regions. In November, OSO was placed in a stowed mode, where it is coasting on its own, so that we may examine its magnetic attitude. OSO-2 can be reactivated at a later date when solar conditions have changed. OSO-3, launched in August, failed to orbit and was lost in the South Atlantic. The experiments lost will be duplicated in the 5th OSO. The 4th and 5th OSOs, scheduled for flight, are in various stages of fabrication and test at the contractor plant. Our present knowledge of the sun has shown clearly the need for a higher precision, higher capacity spacecraft for the study of solar phenomena. Last year, an engineering model of an advanced orbiting solar observatory, AOSO, was completed. The stabilization and guidance system is being built, and its sun sensors are presently under test in a laboratory still room. Experiments have already been selected for several AOSOs. Astronomy, the study of the universe, achieves a new dimension with the ability to put instruments above the Earth's atmosphere. Here, they may measure gamma ray, X-ray, ultraviolet, infrared, and radio wave radiation that cannot reach the ground. In 1965, after 5 years of exceedingly difficult development work, the first orbiting astronomical observatory was being readied for flight. The experiment packages have been tested and integrated into the first flight model. Each OAO will carry the experimental packages of such institutions as University of Wisconsin, Goddard Space Flight Center, and many other scientific agencies and universities. The prototype model completed its qualification tests at the contractor. It is being modified to serve as a later flight spacecraft. Thus, the past year saw marked progress toward providing an observatory in space which can be used by numbers of astronomers, free from the blanketing and distorting effects of the Earth's atmosphere. In 1965, 5 additional Explorer satellites were launched. One of the most important scientific discoveries of the space age has been the Earth's magnetosphere, the region of influence of the Earth in space. It was suspected from the results of experiments carried by early Pioneer and Explorer satellites, and confirmed by Explorer 14 and the first interplanetary monitoring platform, IMP. In May, another IMP, Explorer 28, joined previous satellites to continue study of interaction between the Earth's magnetic field and the solar wind, begun by the first IMP in 1963. In particular, they are exploring the shock wave and transition region on the sunward side of the magnetosphere, and the extended tail with its neutral magnetic sheet on the night side of the magnetosphere. In April, a Beacon Explorer 27 was put in orbit. It is measuring the Earth's gravitational field through Doppler tracking. In addition, its transmitters provide to observers in 36 nations synoptic data on the electron content of the atmosphere. This is a major element in our international scientific program. Another explorer, launched in 1965, was the geodetic satellite GEOS, built by Johns Hopkins Applied Physics Laboratory. It is an active satellite containing flashing light electronic systems and laser reflectors for detailed study of the Earth's gravitational field and a reference for precision mapping. It was successfully launched in November by an uprated version of the Delta launch vehicle, which was being flown for the first time. Also in 1965, a passive geodetic explorer, Pagios, was inflation tested in Lakehurst, New Jersey. It will be launched in 1966. Some satellites built by other nations were launched by NASA in 1965. The ISIS-X was launched in late November. It combined the Canadian Alouette B with the NASA DMEA Direct Measurement Explorer in a piggyback configuration for ionospheric studies. Already, the results of this completely successful experiment have added considerably to our knowledge of the ionic sheets surrounding the spacecraft. The two are orbiting within approximately 1 mile of each other, conducting related measurements. Also, the DMEA Explorer has demonstrated successfully a novel magnetic attitude control system that should be useful for many future scientific missions. The French FR-1 was launched in December. It will investigate very low-frequency radio signals in space. FR-1, like ISIS-X, was launched by Scout, NASA's only all-solid space vehicle. Scout has been used extensively in launching spacecraft for NASA, Department of Defense, and international organizations. There have been 39 launches since 1960. The last 12 consecutive firings have been successful. Like explorers, the sounding rocket is an economical, reliable, and versatile tool. In 1965, approximately 130 were launched to continue the investigation of our atmosphere and to carry out exploratory space experiments. In February and March of 1965, the year of the quiet sun, 77 sounding rockets were launched from the military sea transport Croatan. Launchings took place along the west coast of South America from Colombia to Chile. The Mobile launch expedition was managed by NASA's Wallops Station, and the experimenters came from NASA centers, other government agencies, industrial laboratories, and universities. Scientists and government officials were welcomed at many of the ports visited. Over 95% of the launches were successful. The most important of the scientific accomplishments was the ability to conduct our first rocket measurements of the ionosphere from equatorial regions. Sounding rockets have been launched for scientists of many nations at Wallops Station, Virginia. In August 1965, an international meeting was held there under NASA auspices to set up an inter-American meteorological rocket network. NASA's Sustaining University program is providing grants nationwide for graduate training, scientific research, and laboratory facilities that support and encourage fundamental space science research in the academic community. In 1965, more than 3,000 pre-doctoral students worked under NASA training grants. They were in universities in each of the 50 states. 70 received their PhDs during the year and are doing teaching or research in government, industry, or universities. During the year, Sustaining University program research grants totaling more than $13 million were made to 45 universities located in 27 states. Their interim or final results were a significant factor in space science accomplishments. Space science and engineering laboratories, wholly or partly funded by NASA, were put into service at 12 institutions during 1965. 5 more had been previously completed, and another 16 are underway. The academic community joins with industry and government in the national space effort. And a national effort it is. Scientists and researchers from the colleges and universities, engineers and scientists, administrators and technicians at contractor plants throughout the country, and the scientists, the project managers, the engineers and technicians at NASA field and launch centers, this is the team. These are the men who made 1965 a year of success for space science and applications. Some of the highlights: there were new uses for communication satellites already in orbit, and meteorological satellites with the capability for greatly increased weather coverage were placed in orbit. Useful results came from the scientific and technological experiments programmed for astronauts during manned space flights. And there was progress in the development of a biosatellite to carry other life forms and experiments into the space environment. Centaur, NASA launch vehicle for Surveyor, was launched successfully to complete the first phase of its development program. It was a year in which our knowledge of the Earth, the Sun, and the physical nature of the universe was increased by the scientific information returned from orbiting laboratories, and by explorer satellites, Pioneer space probes, and various sounding rockets. Our most spectacular successes were the lunar photographs of the Ranger series, and the pictures made by Mariner 4, which gave man his first close look at the surface of Mars. These were highlights of 1965. Now, we look to the future, to the new challenges and the continuing opportunities in that limitless laboratory, space.